Hello students, our next topic is Newton's second law. The statement of Newton's second law is the rate of change of momentum on a body is directly proportional to the force acting on it, and the change of the momentum takes place in the direction of the force. Once again, what is force? It is the rate of change of momentum on a body. And the change of momentum takes place in the direction of the force. So, the change of momentum takes place in the direction of the force. These are the 2 points we should understand from the statement. First one is that force is the rate of change of momentum, and the change of momentum takes place in the direction of the force. Right? Now, we have to define mass and force by some experiments. So you know this is our linear air track. We have dealt and done videos in this about this linear air tracker. We do this experiment to define mass using the linear air track. So our experiment to define mass. First of all, we pull the rubber band. You can see a rubber band here. We pull the rider along this direction. We pull the rubber band to a standard length. What happens? This rider moves with uniform or constant acceleration. Let it be A1. So when we pull a rubber band to a standard length, the rider moves with uniform or constant acceleration A1. Okay. Now when we add more mass on this rider and pull the same way, that means we apply the same force as this case. Okay, what happens? It moves with some another acceleration A2. Okay, when we add mass and pull the same way, the rider will move with an acceleration A2. What can we say about these two accelerations A1 and A2? Which will be greater? That means A2 will be less than A1. Why is this so? Because we have increased the mass. So that means when mass is increased, acceleration is decreased. When mass is increased, acceleration is decreased. Now, what are the conclusions we arrive from the experiments we did? First one is, mass is inversely proportional to acceleration. M proportional to 1 by A. That means when mass increases, acceleration decreases. Or when mass decreases, acceleration increases. Or we can say it in an equation form as M into A. Mass into acceleration is equal to a constant. This is the first conclusion we derive from the experiments we did earlier. Okay. Or we can say it in another form as M1 into A1 is equal to M2 into A2. That means product of mass and the acceleration is always a constant value. Let M1 has an acceleration A1, then M2 is defined as M2 is equivalent to M1 into A1 by A2. This is from this relation. Similarly, we can define some another mass M3 which is equivalent to M1 into A1 by A3. Similarly, M4 is equivalent to M1 into A1 by A4. From this relation, we derive at a conclusion that mass ratio and acceleration ratio are same. Mass ratio means M1 by M2 or M1 by M3. That ratio and acceleration ratio A1 by A2, A1 by A3, etc. are always the same. Okay. Another point is that mass is a property which is independent of the source of the acceleration. It does not depend on the source of acceleration, and mass is the inherent property of the object. So, mass is a property which is independent of the source of the acceleration, and it is an inherent property of the body. Now we have to do some experiments to define force. We do this same linear air track experiment. First, we apply a force with a rubber band. Let its acceleration is A. Okay. Now apply the same force with two rubber bands side by side in the same direction. The second step is apply the same force with two rubber bands side by side in the same direction. So what will be the acceleration? It is 2 times A. Here it was A. Then if we use the same, we apply the same force with two rubber bands, acceleration becomes 2A. Right? Now apply these two forces in opposite direction. This is third point. Apply them in the opposite direction. What will be the result? The resultant acceleration will be 0. Okay. Now the inferences or the conclusions are, first one is magnitude and directions are important. So the magnitude and direction of the force under study are important. That means force is a vector quantity. Okay. Third point is that forces and acceleration obey superposition principle. Okay. Fourth one is that acceleration produces several forces acting on a body is equal to the vector sum of the acceleration produced by each of the forces acting separately, which is the superposition principle. This can be acceleration or force. Acceleration or force produces several forces acting on a body is equal to the vector sum of the accelerations produced by each of the forces acting separately. Now we can establish a force scale by defining the unit of force as the force that produces unit acceleration when applied to the unit mass. It follows from our experiments that F units of force accelerates the unit mass by F units of acceleration. From our definition of mass, force will produce F into 1 by m units of acceleration when acting on the mass m. Right? Hence the acceleration produced by force F acting on mass m is A, that is equal to F by m. In a more familiar order, we write it as F equal to ma. So our second law finds to be F equal to ma. This is a link for the linear air track experiment for the second law. You go through this video and try to find out what are the points which has discussed in that video. Thank you.